Hello guys, so this is our third tutorial, which is basically the continuation of the previous tutorial where we created a geometry of the pipe grid model. So in the next step, now we are creating the model that involves defining and assigning the material and sectional properties. And over here we'll create a single material consisting of temperature dependent, linear elastic, and power law creep material properties. So now we go on, we expand this pipe intersection and double click on materials to create a new material. The name of the material is, keep it as creep over here, and go to mechanical elasticity and we choose on elastic. So now what we do is we toggle on the temperature dependent data. Over here we will add the values of Young modulus and Poisson's ratio based on different temperatures. So first of all, at 100 degrees Celsius, we add the values. Similarly for the Poisson's ratio as well. So the next we add the temperature, we put the temperature as 200 and the corresponding Poisson's ratio and Young's modulus. We add the temperatures up to 600. So now you see that the six values of temperatures and corresponding Poisson's ratio and Young modulus have been assigned. So now we go on over here in mechanical tab again and we press on expansion. So now what we do is we add the expansion coefficient, but before doing that we turn on the use temperature dependent data option, we toggle it on, and now again we add temperatures from 1 to 600. So now again we add temperatures from 100 to 600. So as you can see, six coefficients for the six temperatures have been added as well. Now one last thing before pressing OK, we go on to the mechanical tab again, onto the plasticity, and we select creep option over here. So over here again, we'll add values for the power law multiplier which is 2.5003 e power minus 59. Equation stress order as 6.62, and the time order is kept at 0.0. So now we press on OK. So the material based on our specifications has been created. Now we have to define section properties, and what we do is we double click on sections, create a section, and we name it as solid section, and it's kept as homogeneous and solid. Press on continue. In the edit box, edit section dialog box, uh, we keep everything as it is. What we do is uh, we go onto the parts over here and we expand this. Now, like before, we have to go onto the section assignments, double click on this, and we have to assign a section to the part pipe intersection. So what we want to do is we want to select the entire part as a region to which the section will be assigned. So you can see the entire part is highlighted. Press on it. Now it has been selected, and we click on done. So in this dialog box, we accept it, everything as it is, click on OK, and the section has been assigned. Moving forward, we go on to the model tree again, and over here we go on to the assembly instances. We double click on it, and over here we choose the instance type as independent. Remember, this is very important for this model. And after that we click on OK, and now you can see the assembly has been created. Now our next step is to define the steps and specify output requests. So for this model we need basically two different steps, and both of them are the first step is a pressure load, and the second step is a transient analysis, which is carried out to determine the creep of the pressurized vessel. So we go back to the model tree. Over here in the steps, we want to create two steps. So the first step is named as pressure, and we accept the general procedure type. Press on continue. In the description, we can write that apply internal pressure, and other than that, we don't change anything and accept the default settings. Now we double click on this steps tab again. So in this, for creating the second step, we name it as creep and insert the new step after the pressure one. And over here we select Visco rather than static general. Press on continue. This edit step dialog box appears, and over here we can, in the description we can write it transient creep. So the time period is kept to be 4.38 e to the power 5, and in the incrementation tab the maximum number of increments is kept as 1000, whereas the initial increment size and the minimum increment size is kept as 1. The maximum is kept as same for 4.38 into 10 power 5, and the error tolerance is kept as 1 into 10 power minus 5. We don't change anything else in this dialog box. Press on OK. So you see the steps have been created: the initial step, pressure step, and the creep step. Now to uh, obtain the uh, outputs as per our requirements, we define a set, and in the model tree we go back to the assembly section, and over here we double click on the sets option, name this as out, continue, and we select this point, the point which you can see over here. We select this point, click on done. Now we specify the output request, and in this model tree we go on to the field output request tab, right click on it, and we go on to the manager. Over here we first click on the propagated option, and go on to edit, and this edit field output request dialog box appears. Over here we put the increment as 2, and other than that, what we have to do is we go on to the stresses tab. We don't change anything over here, keep it as default. In the strain tab we uh, toggle off the plastic strain component, equivalent plastic strain and plastic strain magnitude. We toggle it off, and for the forces reactions we toggle this off. We don't need these, and we don't need these as well. And over here we toggle on the U components. Now we press on OK and dismiss it from here. In the history of output requests, right click again and go on to the manager. This time we select on the created tab under the pressure and select edit. Over here we change the domain and select set over here, and over here we press on out. The number of increments again is set as 2, and other than that we toggle off the energy tab. We don't need these values, but in the displacement tab we turn on the U components only. We don't need anything other than that. After that we press on OK and dismiss it. Now moving forward, we have to apply the boundary conditions and the loads. So to first apply the boundary conditions, we go onto the model tree again, and over here double click on boundary condition. So we name this boundary condition as X symmetry, and keep everything as it is, and select the step as initial. So here it's symmetry, anti-symmetry in caster, and press on continue. Now we have to select the regions where we want to apply this boundary condition, and we apply it over here, and we press on shift so we can apply it over here as well, correspond at the same time. Now pressing on done, we apply the boundary condition. Over here we toggle on the X symmetry option, press it on OK. You can see the boundary condition has been applied over here. Now we repeat the steps for a different face and different symmetry. We name this as Z symmetry and keep everything as it is. We choose this face and done, and you see the boundary condition has been created. Now to satisfy the end gap condition on the intersecting pipe, we apply a displacement constraint which is normal to the entire face of the free end of the pipe, and again we create another boundary condition for that. To do so, we name the condition as end gap and select as initial, and over here the type of the selected step is displacement / rotation. Press on continue, and we choose this face and press on done. So now over here we select the U2 option, we toggle this on. Other than that, we don't need to change anything, and we press on OK. So the boundary conditions have been applied, and now we have to apply a pressure load. So for doing it, we go onto the load tab, double click on it, and we have to create the load, and the step is pressure. The name of the load is kept as internal pressure, and the selected type of step is pressure, and press on continue. Now we have to apply the load at this phase and press on shift again, and this phase, and press on done in the prompt area. So over here the uniform pressure is specified as 1.4 e to the power 7, and press on OK. So you see the load has been applied on these two faces, and now we have to apply a pressure load to impose the end cap condition on the pressure vessel, and for doing that we repeat the steps and just apply the pressure of a different magnitude to another region. So for that we slightly need to rotate our model, and we have to apply the load on this face. So double click on load again, and type the name of the load is vessel end cap, and it's everything is the same over here. Press on continue, select this face, done, and the magnitude over here is minus 8.281 e to the power 6. Press on OK, and the load has been applied over here as well. And now we have to apply the initial temperature, which is extremely necessary. And to do that, we go on to the predefined fields tab, and we double click on it. This dialog box appears, and the name is kept as temperature. Step is kept as initial, and in the others category, we keep it as temperature and press on continue. Now we have to select the entire part instance as the region to which the field will be applied, and as the region to which the field will be applied, and we start selecting the entire part. Use this uh, option to rotate. Just to confirm that no part is left, rotate it again. Seems as if all the parts have been selected. And what we do is we press on done, and this dialog box appears, and over here we specify the uniform temperature of 540 degrees Celsius. Press on OK. we have applied an initial temperature. So basically, this is what we'll cover in this tutorial. And in the following tutorials, we'll be discussing more about how to apply a mesh and the results. Thank you.